Hello everyone, welcome back to my YouTube channel Data Speaks. In this video, we are going to talk about the data structures tuples. Out of all four different data structures, list, tuples, sets, and dictionaries. In other videos, we have talked about list, which are ordered and mutable sequence of elements, and sets are more of the unordered collection of unique elements, and dictionaries are more of the unordered collection as well with the keys and value pairs. Here we're talking about tuples. The tuples are ordered similar to list, and but they are immutable sequence of elements. List could have been changed, could have been modified. Tuples cannot be, and they are designed in such a way that you can store the organizational information, credentials. Those should not be changed. They can also store different data types similar to list. The tuples start and end within parentheses. And here is a quick example. Here we are going to dive super deep into the tuples and understand why tuples are really important from the data storage perspective, from maintaining the data integrity, data security standpoint. Quick definition here: tuples are one of the built-in data structures. So built-in data structures are lists, tuples, sets, and dictionaries to collect the data, store the data. They are ordered, immutable, and allow duplicate values. You can store multiple sets of same values. Think about tuples to be read-only list. Once it is created, you cannot change at the index level. If you had to change or add or delete, you have to redefine the tuples. You cannot do at the index level. That makes the tuples to be very memory efficient comparing to list. Let's see one example of tuples, which is coordinates. Here I have named the tuples variable coordinates, and I have stored two values here. If you run that, and if you check the type of coordinates, you can see that it's a tuple. So tuples have opening and closing parentheses, and have assigned that tuple to coordinates. Couple of more examples on how to create tuples. Let's create a tuple called fruit tuple, and we want to put a couple of fruit names here: apple, banana, cherry, blueberries, berries. If I run that, if I print the type of fruit tuple, it's going to give class tuple. You can also define the tuples without parentheses. If you just put the numbers in the sequence or values in the sequence without even parentheses, you can define the tuples. If you check the type of numbers, it will give you tuple. So you can create a tuple with just the values separated by comma or by adding parentheses at the beginning at the end of the values. Let's create another example of tuple, and I want to create a tuple with single value. It's just a single. I want to add a value, New York. If I run that and check the type of single, surprisingly it's a string. But why it is not tuple? Because to have a single value to be of tuple type, the qualifier is comma at the end. So that is required by Python. It's a type of how it is designed to have single value as a tuple with open close parentheses. If you check the data type now, it is tuple. Tuples are ordered, and you can access the values of tuples by using indexing similar as list. Let's define a tuple called animals with the different animal names, and we'll try to access the values of this tuple at the index level. So let's confirm and check if this is animals is the tuples type. So this is a tuple. Perfect. Let's try to access the value kangaroo. If I would like to check the value at the index level, I can use the index position of kangaroo. Python indexing starts from 0, so we can count the index position for kangaroo. Elephant index position 0, tiger 1, kangaroo 2. If I put 2 here, as a result, I'm going to get kangaroo. This is how we can access the elements of tuples at the index level. If you want to get all the values of tuple animals from the index position 1 up to, let's say, 5. So how I can access that is I will call animals from 1. If I want to get up to 5, I can give the index position 6, because in Python indexing, first included, last is excluded while we try to access the elements. While trying to access the elements from index 1 to 6, we have got the values from index position 1 up to 5 here. So index position 1, 2, 3, 4, and 5. Sixth index element is excluded, that is zebra. Now this is how we can access the elements of tuples at the index level. You can also access everything up to index position 5. So how do we do that? Is animals, and you want to call everything up to index position 6. So 6 is going to be excluded, so we'll get the values up to index position 5. 0, 1, 2, 3, 4, and 5. So here, if I would run that, we're getting elephant, tiger, kangaroo, penguin, giraffe, and panda. And you can also perform the negative indexing into the tuple as well, same as the list. You can call negative 1, which is the last element in the tuple. If I run that, I'm getting the last element here. Likewise, you can call the range. You want to call from negative 4 up to negative 1. Here, we will not get the last element. It's going to be from negative 4th index or 4th last up to negative 2 or second last element. In this case, if I would run that, I'm getting zebra, koala, and dolphin. So dolphin here, so zebra, koala, dolphin. This is how we can access elements of tuples using index positions. You can use the positive indexing, you can use the negative indexing, and you can also use the negative indexing single value, negative 3, so third last value. So in the tuple, last value, second last, third last. Here we have got koala in that case. So accessing tuples at the index level is the same as the list. You can always access the values or elements using index positions or range of indexes. Despite the popularity of data structured list, tuples are more secure and more reliable because they are immutable. Tuples, once defined, they can not be changed at the index level and the value level. Let's check the immutable property of tuples with an example. We have been using a tuple called animals from the beginning of this tutorial. Let's see what all the values are there here. Okay, so we have elephant, tiger, kangaroo, penguin, giraffe, panda, zebra, koala, dolphin, and hippopotamus. Now, if I would like to delete the last element of this tuple, I would do animals.pop. Let's see if I can do that similar to list. So tuple has no attribute pop. Let's try to do at the index level. Animals.pop. I want to remove the third index value. And again, tuple has no attribute pop. How about removing some value at the value level? I want to say dot remove, and I want to remove hippopotamus. That is the last one, or any other. And now tuple has no attribute remove. I want to try one more. Animals dot, so at the index position -1, the last value, I want to replace with rhino. And now tuple does not support item assignment. This is how tuples are immutable. Once assigned, they cannot be changed at the value level or at the index level. They are immutable. Once defined, it cannot be changed. That is why the tuples are used by organizations to store passwords, geocoding, server addresses, user IDs, etc., because it maintains the security and integrity of the information that is not supposed to be changed, which actually will not be changed once defined, unless somebody goes at the root level and changes over here, Rhino, and now it is changed. But it is really difficult unless somebody is intended to do that. Nobody can change at the root level. Tuples are reliable and trustworthy data structures to store those values that are sensitive and important for the organization, and the organization do not want to change those. We can create tuples inside tuples, similar to list. For example, I want to create a nested tuple, which is 1, 2, 3, 4, 5, 6. In this tuple, we have smaller tuple inside the larger tuple. So this way, we can access tuples differently. If I want to print from the very first index, so index 0, index 1. So index nested 1, I want to access 4. So how I want to do that? By saying 0 and 1. If I say 1, 1, I should get 4. This is how you can access the nested elements from nested tuples. Since tuples are immutable, there are only two built-in methods for tuples. Number one is count, and another one is index. So how do we use it? Let's define a tuple with people's names. I'll put that in a single line. And in this tuple, what I want to do is I want to count someone's name and check how many times it is repeated. I want to write this method here, print people names, and I want to count Bob. Let's see how many times Bob is repeated. Bob is repeated 5 times. 1, 2, 3, 4, 5. How many times? Let's check it out. How many times Charlie is repeated? I want to say Charlie, and Charlie is repeated 4 times. This is how you can count the elements of tuples if they have duplicates. This is the way you can also find how many times each elements are repeated, and you can check the index of some specific value. If you want to check people names dot index, I want to check index of Eve, and Eve is at the 6th index. The very first value, Eve, is at the 6th index. There are more Eves as well, so here one is another one, here is another one, but you can find the very first value of Eve at the index position 6. I want to check the Elise. Elise is at very first value at the index position 0 in tuple. So having tuples are immutable. You cannot change the value, but you can count the occurrence of each element in tuple, as well as you can find the index position of specific values of the tuple since they are immutable. Additionally, you can check minimum, maximum of any tuples. If you want to check minimum of people names, you will get Elise. It will check alphabetically. If you want to check the maximum of people name, it will give you George. From the numerical tuple, you can check the minimum. So we have the nested tuple here. If you check the minimum of that, it will give you the minimum value nested tuple. It will give you the maximum as well. If you check the nested of maximum, is 5 and 6. Just to remind you, the nested tuple looks like this. You can define numbers. You can check the minimum of numbers 1, and you can get the minimum 1. Maximum of numbers 1 is going to be 7. You can say numbers 1 dot count of 6. You will get 2, because in the numbers 1, 6 repeated twice. Let's check 7. How many times it is repeated? You can see that 7 is repeated only once. Tuples allow the dataset column pairing with the function zipping. So if we want to zip two tuples together and make it combined tuple as a one single tuple, we can always do that. I have two individual tuple. One is called columns, another one is called values. I want to zip those two tuples into the tuple called zipped. I want to call zip function here. I want to give one is columns, another one is values. If I run that, I have two tuples zipped together. Now I want to convert that zipped into tuples. If I would do that here, now age has been zipped with 28, income has been zipped with 50,000, education has been zipped with masters. So that being said, here now we have age 28, income 50,000, education masters. Somewhat similar concept as dictionary that has a key value pairs, but that is completely different than what we can see here into the value that has been zipped with two tuples here. That is one of the use case to create the dataset column pairing and create the more dynamic tuple using zip function. You can convert a list into tuple or string into tuple. So if I would say converting list to tuples, I have a list called list1 and I want to store a couple of values. I have this list1. Now I want to convert list1 to tuple names. I will say tuple and list1. I want to print tuple names. I want to check the type of tuple names. See that here. Type of tuple names now is tuple, and the list one has been converted to tuple. So list one, it still retains the original type, which is list, but I have created the new tuple variable called tuple names, and that is created from the list. When you call tuple to list, it will be created as tuple. We can also create tuple from single value. Let's say name, and that is Jack. If you check the type of name, here this is a string type. I can now convert this string type of name to be tuple. This will be done at the element level. However, we can definitely do it. For example, if I want to say tuple name, if you run that, it will have the opening and closing parentheses, and each element of the string will be stored as a tuple. I can always store the tuple name in an element. Say tuple name equals tuple name. And if you check the type of tuple name, it will be tuple. You can change different data type into data structure into tuple, different data type into tuple easily. I want to review the last item in tuple, which is called tuple unpacking. Basically, tuple unpacking is the process where in Python, where individual elements of a tuple can be assigned with multiple variable in a single statement. So each element of tuples can be assigned to different variable in a single statement, which allows you to extract the values from tuple and store them into the separate variables at once. It is useful because it makes a cleaner code cleaner and more readable. It helps in simultaneously assigning multiple values of tuples into many variables. And you can use into loops and function returns and for the purpose of data preprocessing or data processing. Let's look at some of the examples of tuple unpacking. I will begin with a very simple example. I have a tuple called my tuple, and that is with 1, 2, 3. You can assign those 1, 2, and 3 to A, B, and C by just calling that. So make sure you have the same number of variable as same number of elements in tuple. Simply then say A, B, C, and my tuple. And now if I run that and I would print A, it will give me 1. I print B, give me 1, it will give me 2. I will print C, it will give me 3. That means these individual elements of tuples are assigned to A, B, and C in the same way if you would say A equals 1, B equals 2, C equals 3. It's happening exactly this way. So it is this assignment is the same way of saying this. So this is really powerful and very used technique to do the tuple unpacking. So in the tuple unpacking, there are a couple of rules you need to be careful about. The number of variable must match the number of elements while tuple unpacking. So these values should match these variable counts. So there are 3 elements in this tuple. So there should be 3 values in the variable assignment. And if the count does not match, it will raise error. Let's take this example again. I want to put it here. If I say just A and B, let's see what happens. I will get the error here. Too many values to unpack. So these are too many values to unpack into A and B. That's what the error we get. So we must match the count of number of element with the same as number of variables we want to unpack into. Let's look at the another way of tuple unpacking. So when we said we need to match the variables as the same as number of elements in the tuple, what if we want to assign multiple values of or elements of tuple in a single variable? In that case, we can begin with a tuple name, which we want to call destinations. And here we want to put some city names here. Tuple contains Tokyo, Seoul, Bangkok, Bali, Singapore, New Delhi, Kathmandu, and Jakarta. So in these cities, what we want to do is we want to have the tuple unpacking in 3 different variables. I want to call first stop, and then I want to call journey middle. I want to call second the final stop, as we want to use the tuple destination. So we're unpacking these all of these tuple elements into 3 variables. Earlier, we said we need to have number of variables as the same number of elements in the tuple. However, if you add a star, what will happen in this specific variable assignment or tuple unpacking is Tokyo is going to be assigned to the first stop, and final stop, the Jakarta is going to be assigned to the final stop. All remaining values or elements of tuple are going to be assigned to journey middle, since we have a star that says everything that is in the middle, and we have assigned those to journey middle. If I run that tuple unpacking, if I print the first stop, you will see Tokyo. If I print final stop, then it's gonna be Jakarta. If I print the journey middle, you will see that bunch of elements are assigned to journey middle from Seoul up to Kathmandu. So that is how we can dynamically create variables based on multiple tuple unpacking or assigning multiple elements of tuple to a single variable. This is a very dynamic way of assigning values or elements of tuple to different variables, which is called tuple unpacking. We have covered almost everything about tuples data structures. In other videos, we have covered about dictionary and sets data structures. Please do not forget to check those videos. If you have not already subscribed to my YouTube channel, please do subscribe and turn that bell icon on so that whenever I upload a new video, you will get instantly notified. Thank you for watching this video. I'll see you in the next video.